Hi, Hunter. Hi, Hunter. Oh, hi, Hunter.
Hey, I just I enabled the audio. I couldn't hear anything.
Oh, no problem. Got anything you need to talk about?
No, not in particular. All good.
Okay, good enough.
Looking forward to learning more about moles and how to convert atoms to moles and G's and all this.
It's just simple. It's simple dimensional analysis, Hunter. Just simple. You're going to have one thing. You're going to try and get another.
Mm-hmm.
And there are 6 relationships between them. And we'll get that. It's really and truly, there's really not that much to it.
All right. I'm gonna stop talking here for a second and get my ducks in a row. I guess that's the saying.
No problem. Omar, you doing okay? Omar?
Hello.
Hi, how you doing, Omar?
Good, thank you.
Oh, good. Do you have anything you need to talk about?
Actually, yes. I just needed to talk about a few of my assignments.
Okay.
I know lately I haven't done, most of my assignments. I do apologize for this. I didn't mean not to do it, on purpose or
Are you
anything. But
talking? Are you talking about the quizzes, Omar?
yeah, unfortunately. And the homework question, I just found out about this. I didn't know when you posted the question that was like considered a homework.
Well, Omar, the homework's been there the whole time. It's do you know where to find it now?
I do, yes. I just found out recently about it. I just didn't know at first that it was a homework to answer this.
Yeah, you will get penalized 20%, but you can still hand in the homework. Okay.
Okay.
The quiz,
And what?
the quizzes,
Yes.
I'm afraid, once they've gone, the answers are published, so I can't do anything about that.
So
Okay.
there's no chance of getting the quiz. I can get it proctored if you want.
Nope. Sorry, Omar. The quizzes the answers are already out there.
You can maybe change the answers for me.
No, Omar, I can't. That's too much work. I'm sorry. I can't do that. Each one of those quizzes, Omar, each one of those quizzes takes me 2 hours to do.
Oh, I
So-
see. Is there anything like as a replacement? Like I can
Nope.
do maybe a homework, an essay, anything?
Nope. Sorry. There's nothing I have out there, Omar. You get to drop 2 of them. You get to drop 2 of them.
I know, but I mean, I actually have a lot that it's like past due. I didn't take him, and some of them closed while I was still doing it. So the thing, if I couldn't do him, then I'm gonna fail the class. I know that.
Omar, I'm sorry. I've been there the whole time. I mean, I feel for you, but I'm sorry. That's we're halfway through the class now, Omar.
Right. No, I do apologize. I know it's my fault. It's just like been, hard for me to maintain work in 5 classes.
I understand that. I understand that, and unfortunately, maybe next time you don't take 5 classes. I don't know what to tell you, other
Right.
than other people have been managing it. Okay.
So there's no replacements for any quizzes, right?
No, I dropped 2 of them.
I see.
I give you 20, you get to drop 2 of them. So they're worth 180 points.
I see. And for the big test, the one we took proctored, is there a way I can maybe like redo this or no?
Well, the tests for the tests, what happens is if your final grade is a better percentage wise than any one of your tests, the final will replace the test.
The final replace. I see.
Yes.
So all I can do now is just like the homework questions, and then on my lab.
The lab has nothing to do with the lecture.
I mean, like Pearson.
Yeah. you do the homework. Do the homework, do every quiz that's left.
I see. Okay, thank you.
You're welcome. Zaina, Armitha, do you have any questions?
No, just joined a little early.
Okay, no problem.
No.
I'm just sitting here doing my puzzles, so I actually got all my work done. I'm caught up. That is until the lab tonight. Then I get more questions, more things to answer.
I have a question.
Yeah, Hunter.
What's the most exotic element you've ever seen in real life?
What is the most exotic element I've seen in real life? Donald Trump.
Come on. Yeah, exotic, I guess.
Probably be gallium. Gallium's a kick because what happens is it's a metal that melts. It melts when you heat it up. So what you can do is you can like mold a spoon out of gallium and put it in your coffee and pull the spoon out and it
Sounds
will be.
so dangerous.
I'm sorry?
That sounds so dangerous.
It is.
Coffee.
It is. You don't want to be drinking the coffee afterwards.
Oh.
Chase, you're not the first one in tonight. What's happening?
I was playing Call of Duty and the game went long. Sorry.
I'm glad you have your priorities set. I mean, I'm just sitting here doing my puzzles. I actually finished everything except the wonder word today. And that's the easiest one of them all. So just excitement left and right. What can I tell you? Armitha, we doing okay?
I guess.
Oh, what do you mean you guess? What's going on?
I don't know. I just understand. I don't understand this stuff. So I guess that's like.
Okay. What I want you to do is I want you to go into the course. Okay.
Mm-hmm.
Go into the individual sections. When you get into the individual sections, there's something called the online outline.
Yeah.
And go through there. There are videos. Maybe the videos will help.
Okay.
I mean, are you at a point right now where you even know enough to ask a question, Armithia?
Yeah, I did
Okay.
pretty well, but it's just like I got confused at the last two questions on the
Quiz?
yeah.
It's been I haven't looked at the quizzes since Sunday, so I really don't know what they were about.
Oh, okay. It was like oxygen. It's like the filling the mass of oxygen or something like that.
Okay, let me see if I can pull it up. Okay, you seeing the screen?
Yeah.
Okay. And we're looking at the last quiz, correct?
Yeah.
That would be 10.
Yeah.
We're into quiz 10 already?
Yeah.
Wow. Okay, last two questions.
Yeah.
Okay. What you have to know for this is you have to know that the magic number, the molar volume is 22.414 liters per mole at STP. 1 atmosphere pressure and 273 degrees Celsius are STP. So if you have 1 mole of oxygen, you would have 22.414. But you have half that volume at STP. So how many moles do you think you have?
1.3.
No,
I mean,
no, no, no,
1.2.
no. You have half the volume. If 1 mole equals 22.414, how many moles do you think are 11.207 or half of the volume?
12?
No?
I don't know.
Okay. All right, let's see if I can get this. All right. Okay, let's do it this way. If 1 dozen is equal to 12 eggs,
Mm-hmm.
if you have 6 eggs, how many dozens do you have?
Half a dozen?
Half a dozen, okay? So if 1 mole equals 22.414 liters, okay? Half of that volume is equal to how many moles?
Half of a
Half a
mole.
mole. Half a mole, absolutely. So we defined a mole as 6.022 times 10 to the 23rd, right?
Yeah.
So half of a mole is going to be 3.01.
Oh, wow.
It was just a logic question that you had to work your way through.
Yeah, it's a bummer.
Okay. Next question. There are 1 mole of oxygen used up for every 2 moles of hydrogen. So basically, if you have 6.02 times 10 to the 23rd atoms of oxygen, you're going to use twice that many molecules of hydrogen, right?
Mm-hmm.
So if you have 4 e to the 18th molecules of oxygen, you're going to use twice as many of hydrogen. So the answer to there is 8.00 e to the 18th.
I put that, but it said it was wrong.
You see, I haven't changed it. If you don't mind, I will look up your quiz.
Yeah.
Sometimes you got to be careful because this is how I get wrong answers put into questions. And that is sometimes just the act of getting out of something clicks it to another answer. So that may have been what happened, dude. That's why you got to look at your answers before you click that submit button.
I'm good. I got it though. I knew it was 8. I put an 8 and then just said it before.
Sorry, Amithia, what's your last name?
Howard.
Okay. There we go. Again, you don't mind my showing this.
I don't care.
I have to ask because it is your personal thing. I had you a second ago. There we
That's
go.
it.
Anybody else have any questions while I'm dealing with this? Okay, I gotta put this over here so I can see things. Okay, you got that answer right, Omithia.
Yeah. But when it said it was wrong when I graded it.
No, you're seeing the thing up here right now.
Oh, okay. Okay.
So you got that one right.
All right.
Okay. Okay, ladies and gentlemen, anybody have any questions?
Yes.
I have an answer. Come on, ask the question.
Weird question, but do you always wear a hat?
Do I always wear a hat?
Yeah.
Now do you understand why I wear a hat?
I don't see anything wrong with that.
No, be honest with you, if you see me on Fridays when I'm doing an in-face class, I don't wear the Hawaiian shirt, and I'm generally in a dress shirt and tie, and I don't wear a hat. What
You
can I
should
tell
wear a
you?
hoodie next class.
I should wear a hoodie.
Yeah.
You have any idea how heavy my hoodies are? I have sweatshirt hoodies. I don't have a light hoodie.
I'll mail you one.
I'm afraid if I wear it that I'm going to get accosted by the police somewhere.
It'll have like a chemistry joke or something on it, so they won't be suspicious.
Yeah. Anybody have anything serious? Is that you, Zayna, talking like that?
That was serious.
Oh, I'm serious. Anybody have any serious questions? Okay, ladies and gentlemen, depending upon where we end up tonight, you will have your test either on Tuesday or Thursday. The reason I'm pushing for Tuesday is because the next chapter has a lot of confusing things on it. I want to be able to spend more time on those. Okay? But if you so, this is entirely up to you. It's your class. If you want to spend more time on what we're doing today, we could get through and do a review on Tuesday. Or we could spend the time on the more complicated thing. I'm hearing crickets, guys. I'm not hearing any sort of input. What's that?
I like the sound of reviewing it on Tuesday. That sounds good to me. I like that.
The
I
trouble,
would like some more practice on moles, the conversion, either today or next week.
okay, I don't mind doing that. I mean, that's again, there is no free ride anywhere. If I do that, then what happens is I can have one less class period to talk about empirical formulas and stoichiometry. It's a trade-off, guys.
So would we be discussing those two things then on Thursday?
Empirical formulas and stoichiometry?
Yeah.
No, we would be discussing empirical formulas.
Okay.
I'm not totally against the idea because I don't like the idea of my teaching you something, then you guys going off for a week and then coming back to try and reteach the same stuff again. So I'm not totally against having a review on Tuesday
Okay,
yeah.
what day is the test?
Tuesday.
or
Okay,
Thursday. That's what we're deciding.
Let's do it on Thursday and do a review on Tuesday. That makes most sense to me.
Yes, I completely agree with that.
Again, you guys have to realize that you are robbing Peter to pay Paul. You are literally taking up one of the classes in the next chapter, and those subjects I think are a little more difficult. But if this
Well,
was,
we have to do a review in class either way, in my opinion.
I think if we focus really hard on the moles today, which is today's classes, we should be good.
I'll be done with moles. There's no question I will be done with moles today. It's not that difficult a thing.
Then is there any way, I mean, people are probably not going to like me for this, but if we get through moles really quickly, we could just do a review?
I think that's a good idea.
Yeah, that's good.
Because we also have all that extra homework that he provides.
Yeah.
Let's go. Let's give that a shot then. Okay.
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 All right.
We'll just see where we end up. All right. I'm going to get out of this top share and I'm into time now. Okay. Okay. Show sound. You seeing the screen?
Yes.
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your ant's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe, or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you have equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amadeo Carlo Avogadro. Wonder how long it took him to sign autographs. Unfortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Unfortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particles. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind. Avogadro was the first one to come up with this idea, scientists named the number 6.02 times 10 to the 23rd after him. It is simply known as Avogadro's number.
Professor, can you turn the volume up?
Not
All
that
right.
mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles are hard for students to understand because they have a hard time picturing the size of a mole, or a 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? Maybe this will help. Exchange the water particles for donuts. If you had a mole of donuts, they would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You'd really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. Okay, now we sort of have an idea how large the mole is. So how do we use it? You might be surprised to know that chemists use it the same way you use pounds to buy grapes, deli meat, or eggs. When you go to the grocery store, you don't go to the deli counter and ask for 43 slices of salami. You buy your salami by the pound. When you buy your eggs, you buy a dozen eggs. When we hear the word dozen, we probably think of the number 12. We also know that a pear is 2, a baker's dozen is 13, a gross is 144, and a ream of paper is... anybody? A ream is 500. Well, a mole is really the same thing. For a chemist, a mole conjures up the number 6.02 times 10 to the 23rd, not a fuzzy little animal. The only difference is that the other quantities are more familiar to us. So there you have it, the story of the mole, Avogadro, basketballs, and how to buy salami at the grocery store.
Okay. I got to get out of here. Let's get stop share. Good. Okay, guys, you got to get the concept. A mole is nothing more than a counting number, and it stands for 6.022 times 10 to the 23rd of anything. All right. That is what one mole is. It's anything. So if you have a mole of carbon, you have 6.022 times 10 to the 23rd atoms of carbon. If you have a mole of carbon dioxide, you have 6.022 times 10 to the 23rd molecules of carbon dioxide. So we have to keep that in mind when we're doing things. That is one conversion factor, guys. If I have a certain number of moles, I can tell you how many molecules or atoms of that particular atom that I have. But each substance, each element that's out there weighs differently because they have different numbers of protons and neutrons in there. So if I have 1 mole of aluminum, I have 6.022 times 10 to the 23rd atoms, but that would weigh 26.98 grams. If I have a mole of gold, same number of atoms, but that weighs 196.97. So it depends upon the substance I have, how much Avogadro's number of those atoms will weigh. Now, if I'm dealing with molecules, Avogadro's number represents the molecular mass of that particular substance. So I have some relationships. These are my conversion factors. I have 1 mole is equal to Avogadro's number of atoms if I'm dealing with an element. 1 mole is equal to Avogadro's number of molecules if I'm dealing with a molecule. But 1 mole is also equal to the grams, the atomic weight of that element. And coincidentally, if we believe the first 2 relationships, then the atomic weight is also equal to Avogadro's number of atoms. So these are our 3 conversion factors. And if you remember how we dealt with the dimensional analysis thing, if you remember on our dimensional analysis thing, stop it and show. Remember, we figured out what we knew and we figured out what we wanted to know. And all we did was we multiplied what we knew by a conversion to get what we wanted to know. Okay? So when we're in these relationships, if we want to know how many molecules, we're going to have to relate molecules to either a molecular weight, or we're going to have to relate the number of molecules to moles. It just depends upon what we know. Remember, a mole is a counting unit. It can refer to anything. So if I have ions, a mole of ions is equal to Avogadro's number. If I have molecules, if I'm talking about a compound, that's how many molecules that I have. And since they're all equal, I can convert from moles to number of molecules to molecular weights. If I'm going from weight to moles, okay, weight is grams. The relationship we're going to use is 1 mole is equal to the molecular weight in grams. I've got grams on top, grams on the bottom. They cancel out. All I'm left with is moles. So how many moles is 23.495 grams of sodium chloride? I don't know the molecular weight, but I can figure it out because I can look on the periodic table and find that the atomic weight of sodium is 22.9898. The atomic weight of chlorine is 35.453. I add those numbers up, and my molecular weight of sodium chloride is 58.443 grams. That weight is equal to 1 mole. So I have a conversion. I have on my left side what the problem gives me. On my right side is what I want to figure out. I just know that I want moles. So moles is going to go on top. I want to get rid of grams. Grams is going to be on the bottom. So I just have to figure out the relationship between 1 mole and what the molecular weight is.
Professor, quick question. So if it was NaCl2, then we would take 2 times the atomic weight of chlorine.
Yes, if it were something like Na2S, I would multiply 2 times the 22.9898, and that would be approximately 46. And to that, I would add the atomic weight of sulfur, which is 32. So 46 and 32 makes 78.
Okay, thank you.
So if I have weight and I want moles, I'm going to multiply my weight by 1 mole over the molecular weight. If I want molecules and I have weight, I have a relationship between molecules and weight. I know that my relationship is my molecular weight is equal to that many molecules. So if I have weight and I want molecules, I'm going to put my molecules on top, my molecular weight on the bottom. Again, my grams are going to cancel. And what I'm left with will be molecules. How many molecules are in 35.23 grams of carbon monoxide? Need to figure out the molecular weight of carbon monoxide. Carbon is 12.011. Oxygen is 15.999. I add those 2 numbers together. The molecular weight of carbon monoxide is 28.010 grams. 28.010 grams of carbon monoxide is equal to 6.022 times 10 to the 23rd molecules of carbon monoxide. So I simply take the weight I'm given in the problem. I multiply it by Avogadro's number of molecules over the molecular weight of carbon monoxide. This will give me the final number in molecules. Questions, guys? If you don't like that, I can change my grams into moles by taking my grams and multiplying it by 1 mole over 28.010 grams. That gives me 1.2578 moles of carbon monoxide. I also have a relationship between molecules and 1 mole. 6.022 times 10 to the 23rd molecules is equal to 1 mole, so I can put it over 1 mole and I get the number of molecules. Notice both ways that I did this problem, I ended up with the same answer. Are we good, guys? Is this kind of making a little bit of sense? All we're doing is doing dimensional analysis. If I have moles and I want to go to weight, I have a relationship between moles and weight. The moles, 1 mole of my sample is equal to the molecular weight. So if I have moles, I'm going to take the molecular weight, put that on top, divide that by 1 mole. If I have 0.2348 moles of potassium bromide, what is the weight of that? I take my atomic mass of potassium, 39.102. I add to that 79.904 grams for the potassium. This gives me a molecular weight of 119.006. 119.006 grams of potassium bromide is equal to 1 mole. So in order to get the weight, I just put the molecular weight over top 1 mole. Moles cancel, and I'm left with grams. So I do this math out here. 0.2348 moles of potassium bromide is equal to 27.94 grams of potassium bromide. Halfway through, guys. Again, this is all dimensional analysis. If we're going from moles to molecules, I have a relationship. Avogadro's number of molecules is equal to 1 mole. So if I have the moles, I'm going to multiply it by Avogadro's number over 1 mole. If I have 0.6543 moles of KBr, how many molecules is that? I take the moles, multiply it by Avogadro's number over 1 mole. And that gives me 3.94 times 10 to the 23rd molecules of KBr. Victoria. If I have 0.6543 moles of benzene, how many molecules is that?
Benzene?
Yep.
Wouldn't it just be the his number? The number? Why are you asking me math questions, Professor? I'm not good at this.
Because this isn't a math question. This is a logic question. Can I ask you a question, Victoria?
Yeah.
How many molecules of benzene are in 1 mole of benzene?
6.022 times 10 to the 23rd.
So wouldn't we be doing the same exact math as we just did?
Yes.
It doesn't matter what we're talking about. If we're talking about moles of something, then it's going to be just Avogadro's number divided by 1 mole.
What if it was by like 2 moles? Would you just double the number?
I am not understanding.
It was something on the quiz where it was something about oxygen. I think I came in at the wrong, like at the tail end of that conversation when you were talking
Yes,
about it.
exactly. I know approximately what you were saying.
Yeah.
All right. And that is the reaction took place so that 1 mole of hydrogen was related to 2 moles of, 1 mole of oxygen was related to 2 moles of hydrogen, right?
Yeah.
If you have 1 mole of oxygen, it would react with 2 moles of hydrogen, right?
Okay. Right.
So if you had 342 moles of oxygen,
Mm-hmm.
how many 342 molecules of oxygen, how many molecules of hydrogen would react?
And it
That
was. Oh, okay. Yeah. No. For some reason, I thought you had to like double the, or not double the number, but.
Yeah, you did have to double.
Well,
the
yeah,
number.
but I don't know what I'm trying to ask. I think my brain just kaput, so we could just move on.
Okay. Because there is that ratio of 1 hydrogen to 2 oxygens. If I know how many atoms of oxygen I have, all I have to do is double it, and I'll have the number of atoms of hydrogen.
So you never touch the 6.0 or 6.022. You could touch the molecular.
Ouch, that hurt.
Sorry. You could
Yeah,
touch like the moles number, right? So like the 0.6543 can change, but the actual
This relationship is never going to change.
okay.
This relationship is 6.022 times 10 to the 23rd molecules in 1 mole of anything. That relationship will never change.
Got it.
Okay.
Good. Yep.
Now, if I want to go from molecules to moles, all I got to do is flip that relationship around. However many molecules I have, I'm going to multiply that by 1 mole over 6.022 times 10 to the 23rd molecules. How many moles you have if you have 4.563 times 10 to the 22nd molecules? All right. This is how many molecules I have, and I have the relationship 1 mole over this many molecules. Molecules cancels. I divide this number by this one. That gives me 7.577 times 10 to the minus 2 moles. Questions, guys? Is this making sense to you?
Yes.
Yes.
Well, all we're doing is dimensional analysis problems. And we've been given 3 relationships. 1 mole is equal to Avogadro's number of molecules. 1 mole is equal to the atomic weight, the molecular weight. The molecular weight is equal to Avogadro's number of atoms, of molecules. And keep in mind, I can flip this back and forth between atoms and molecules. The last one, I can go from molecules to weight by using the molecular weight is equal to Avogadro's number conversion. If I have the number of molecules, I'm going to put Avogadro's number on the bottom side of that. I'm going to put the molecular weight on top. So how much weight does 9.976 times 10 to the 14th molecules of iron oxide weigh? Iron oxide, the molecular weight, look up iron's atomic weight, that's 55.847. I look up oxygen, that's 15.999. I add the 2 of them together, the molecular weight of FeO is 71.846. So my relationship of molecules to molecular weight in this case is going to be 71.846, since that is the molecular weight of FeO, is equal to Avogadro's number of molecules. If I want to find out how much that weighs, I'm going to put the molecular weight on top of the molecules. Note, guys, I've been using, this whole time I've been talking about the 6 conversions. I have been using molecules and molecular weights. If I was talking about elements, I could substitute atoms and atomic weights, or ions and ionic weights. It's all depending upon what I'm talking about. If I have atoms, I'm relating atomic weight to Avogadro's number to 1 mole. If I'm dealing with molecules, I'm relating 1 mole to Avogadro's number to molecular weight. Okay, I'm going to get out of here for a second. What time? How much time are we talking about, guys?
It's 5:58 right now, sir.
Okay, I'm going to get out of here and I'm going to steal into the extra homework, I think.
So when will the review for test 2 be available?
When will the review?
Like a practice test. Like
Yeah,
you
the
posted for
practice
the last
test.
time.
Because
I
the
think
last
it's a-
time it was like the day before or the day of.
Yeah, that was my mistake.
Are we
I
gonna
believe
have
it's a-
homework on this?
Yes, you do.
Okay, because I don't see it, but I'll look again.
No, I checked Pearson
Okay.
yesterday and I didn't see it.
Good, I'm not the only one.
Okay.
Because I'll kill for that review. Like I need to see that.
Practice tests, Hunter. Up. Guess what? When will you see it?
Yeah.
Okay.
When he said, guess what? I thought he was gonna pull like a rabbit out of his head or something.
He's gonna pull some gallium out of his hat.
I
Not
don't
only
do
is he-
magic, but I can juggle somewhat.
Yeah, juggle 6 classes.
3.
That's a lot.
Nope. Exams. Why is that not in there? I may have to find it, guys.
I think we just saw it. It said test 2 review.
Yeah, I did.
Yeah,
I
I
thought that
know
was
it did. I know it did.
That's probably not the one he was looking for.
Okay. I will find it and I will put it up there. I'll find it. It is in there somewhere.
Need that test 2.
Yeah.
Yeah, if we can get it before the next week starts, we can study. Because I know we all work Monday to Friday.
I'm just trying to get as much time as I can with it. Take it out on a date or something.
I see it. It's at the very bottom. Practice test 2.
You straight eagle-eyed it.
I need that test just as much as you do, Hunter.
I feel you. I'm sitting here like, I need that test so bad.
Why is this taking so long? I'll get it in there, guys.
You don't get any more than practice tests.
I feel that for real. I'm just like, practice test. Good.
Okay. You ask and I shall I'll deliver for you. Okay.
Y'all
I
are
have no
killing
idea.
me and my little brother. My little brother's sitting in here with me listening in, and he's literally sitting on the floor laughing his ass off.
I wasn't even being funny tonight. You ask for them, they are there. The practice tests are in there, all right?
Thank you so
Thank you.
No problem. It's my fault for test 1. And there is an answer sheet for test 2. Do not trust the answer sheet 100%.
Okay.
Okay. Now that I'm in here, now that you have distracted me, I need to get out of here and I need to get into test 2. And this is camera actions. I need the mole. Okay, by the way, guys, this is where the extra homework is. Okay. I will check to see what's happening with the homework I don't believe the homework was assigned until tonight. I think after tonight it gets assigned.
And that's going to be due on Tuesday, probably.
Probably.
Okay.
Okay.
Wish you could just like
Simple
download.
questions. Simple questions, guys. How many moles are in 28 grams of CO2? Are you seeing this or not?
Yes.
All right. Hunter, what goes on the left side? What information are you given?
Say again?
I'm looking at question number 3. How many moles are in 28 grams of carbon dioxide?
Okay, we got 28 grams.
What goes on the left? What
28
information?
grams.
28 grams. What do you want to know? What goes on the right side of the equal sign?
Moles.
So if moles are what you want, are moles going to go above the line or below the line?
Below.
Hunter, if I put it below,
Sorry, I said that way too confidently.
yes, you did. Okay.
It would go above.
No, we're going to do it. 28 grams of CO2. You
Okay.
said the 28 grams, and the question is how many moles? You said the 28 grams goes on the left
Yeah.
and the right side
God,
is
that
moles.
bird. I'm sorry.
Right?
There's an extremely loud bird. Sorry.
Okay. You said that moles is going to go on the bottom, correct?
I did, but it's wrong.
If it goes on the bottom, and by the way, this answer is 44 grams. Now, Hunter, if I do that, look at the problem the way you've told me to set it up.
Yeah, it's wrong.
Okay, what do you have to do?
Put the moles on top.
And the relationship is 1 mole to the molecular weight, which is
Of
44
CO2.
grams. Grams are going to cancel. What's left is moles. So in the case of this, the answer is going to be
Do the math real quick.
0.64.
Okay. So that's 20.
Okay.
Okay, because we're gonna round to 2 sig figs.
Have to round because
Yeah. It's 0.63636364. We just rounded to 0.64. Okay.
All right. How much does 5.43 e to the 24th atoms of carbon weigh? Kaylin.
Hello.
Hi. You look just so serene and peaceful. I thought
I'm
I'd
so
disturb that.
excited to be called on.
Kaylin, this is an easy one.
Okay.
So what do we know in this problem?
How many atoms we have?
Yep. So
That goes on the left.
5.43 e to the 24th. What goes on the right? What do we want to know?
Wait.
Grams, right?
Yeah.
Okay. So this is molecules.
Or atoms.
Oh, I'm saying atoms. Thank you. All right. Do we have a relationship between a certain number of atoms and a certain weight?
Yes. 1 mole is equal to the atomic weight in grams.
Okay. If you wanted to do it that way, you can do it that way. So 1 mole is equal to the molecular weight I'll buy that. But we can't go directly from atoms using weight and mole conversion. I
Okay.
have to use a conversion that's involving atoms.
Okay.
What's the magic number for number of atoms?
Avogadro's 6.022.
Okay. What's that? What do you want to relate that to? 1 mole?
1 mole.
Okay, so I'm going to take 1 mole and I'm going to relate that to what's the number? What's the magic number?
6.022 times 10 to the 23rd.
And what is the answer that will give me?
How many moles?
Okay, stop that. Okay. I do this math out. And I end up with 9.00 moles. Now what am I going to do, Kaylin?
A new equation.
Okay, what is that new equation going to be?
We know moles, and now we need weight. So moles on the left and weight on the right.
Okay. Now, do we have a relationship between moles and weight?
Yes.
Okay. Do you know how much? What
It's
is,
1 mole over the weight of carbon, right?
if I do that,
Um,
if I do 1 mole over what's, all right, you have your periodic table there?
yeah, I do.
And what is that number?
12.011.
Now, is that going to work?
It sounds like the answer's no from the tone of your voice, but I would have thought yes.
Okay. Look, Kaylin, look at the labels you have here.
Oh, we gotta flip it. Moles on the bottom to cancel out.
So I take that and I get, do this, 108 grams. Guys, if you want to do it this way, you can. If you wanted to do it this way, you could. No question, you would get the answer. But Kaylin, do you see
Yes.
that in your first equation, you're multiplying by 1 mole, and in your second equation, you're dividing by 1 mole.
Oh, okay.
They cancel out. You can do the same thing by just taking the atomic weight and putting it over Avogadro's number, and it will give you the same answer.
Okay. I
But
feel like
Kaylin,
that's what I tried to say at first, but it didn't come out right.
no, it's Kaylin, if you want to go through moles,
I don't.
it's a perfectly good way to do things. Okay?
Okay.
All right. New slide. Okay. Terry,
Yes, sir.
you have 0.589 moles. You have to figure out grams.
And I don't know the element.
Oh. What? You have 0.58 moles of chromium.
One moment.
Okay, Terry,
Yep.
what do we want to end up with?
Grams.
So what's going to go on the top?
Moles.
If moles go on the top, I'm multiplying moles times moles. I'm getting moles squared, right?
You want to put grams on top and moles on bottom.
Okay, so I've got to figure out a relationship between grams and moles. What is that relationship between grams and moles when I'm dealing with chromium?
You're looking at 51.996 grams.
And that equals how many?
1 mole.
So all I'm going to have to do, guys, is take my atomic weight of chromium and put that over. Why is this not? Oh, I put italics rather than underline. Okay. So if I have 0.589 moles, I'm going to need to take the atomic weight of chromium, put that over 1 mole. And when I do that, I get 30.6 grams. Now, I want you to star 2 of them. I want you to star 2 of them. I want you to get these 2 down absolutely. Because what we're doing right after this is we're doing empirical formulas and we're doing stoichiometry. And it is critical that you know how to do these 2 things. You need to convert grams to moles. And you need to convert moles to grams. Those are critical. You have to be able to do those 2 things, or you're not going to understand how to do empirical formulas or stoichiometry. Going to stop share for a second. We're going to go and share screen, and we're going to see if we can have a more complicated question. Aspartame is an artificial sweetener that is 160 times sweeter than sucrose. Who cares? When dissolved in water, it is marketed as NutraSweet. Again, who cares? The molecular formula of aspartame is C14H18N2O5.
Is that aspartame?
Yes. What do I say? Aspartame?
Yeah.
You say tomato?
Tomato, all right.
I'm just writing this down so that and okay. Stop share. We're going to go back to share screen. We're going to go back here. C14. H18. N2O5. What is the molecular weight? Remember I said, guys, these things can get extremely difficult. So use the table.
So would you just add up all of their weights together?
Well, this I'm showing you right now how I would do it.
Okay.
You're going to list in the table like this: element, number of them, the atomic mass, and contribution. Element is carbon. How many carbons do I have?
14.
The atomic mass, if you look it up, is 12.011. So in order to get carbon's contribution, I multiply 14 times 12.011, and this gives me,
168.154.
okay, what's my next element, guys?
Hydrogen,
How many of them do I have?
18.
Contribution, or the atomic mass, is 1.008.
18.144.
I'm not gonna even bother trying. 18.111.
144.
Next element.
Nitrogen,
How many of them do I have?
2 atoms times 14.007. That's 28.014.
You're doing this in your head?
Of course I am. Absolutely.
Oxygen,
5 times 15.99. 79.995. You might have a
you're gonna
different
make me
number.
do that.
79.995.
Okay.
Total of 294,307. So with sig figs, that would be 294.31.
Nope, not with sig figs. You're wrong with the sig figs.
I'm wrong. Okay, 3, 4, 5, 6.
All the numbers go out to 3 sig figs, right?
Is it because the last operation you're doing is addition? That's
Nope.
why the
Yeah.
decimal points?
All of my, oh crap, you're right. Somebody's leading me astray. If I'm doing this correctly, this one only has 4 sig figs, so that's going to limit me. Okay, do you see that?
Yeah.
So what was this answer, Rosina?
294.307.
I have to do it that way because my hydrogen is limiting me.
Right.
Okay, we have to keep that number in mind, 294.31. First question I have here. How many grams is, moles is 10 grams? Rosina?
Yes.
Set the problem up for me.
So what is given is 10 grams. So 10 grams times, we need to find the answer in moles. So 1 mole is the Avogadro's number. Hunter said it's Avogadro's number, so that's what I had in mind.
Okay, if you want to do that, we can do it. It's the long way, but if you want to do it that way, I'm going to let you.
Okay. So 1 mole is 6.022 E23. So this is going to give us the answer. Is this not going to give us the answer in grams?
Nope.
Sorry, in moles already?
I'm just doing what you tell me to do.
Okay, so this is not going to cancel out.
No, it's not.
So then we have to find a relationship between molecules and grams.
Okay. Do we know what that relationship is? Somebody help her. What's the relationship between molecules and grams?
Would you put the 294.3 at the bottom?
Oh, I see. Okay.
294.31, yeah.
And that's grams. Okay.
Yep.
So we didn't have to put the Avogadro's number.
Nope, we didn't. So all I'm going to do here is I'm going to take 10 and divide it by 294.31. And this gives me
0.0339. We need 5 sig figs. We need 5 sig figs.
No, you don't. How many sig figs does this have?
Oh, 2.
So how many sig figs is my answer going to have?
Just 2.
Thank you.
So do we get the 1 over 294.331 divided by 10, and then we turn that into a decimal, or
No,
how do we?
no, Curtis. We
Mhm.
started with 10 grams.
Right.
How we started this problem was, Rosina, we started with 10 grams because that's what the problem gave us, right?
Mm-hmm.
And we wanted this, we wanted moles,
Right.
right?
Right.
So if you're doing this the way I first taught you to do it, it's going to drive me crazy. I could do this so much easier with a whiteboard and some eraser things.
Is that 294.31 the molecular weight?
Yes.
Okay.
All right, Curtis, I want to put moles because that's what I'm ending with, right?
Right.
And what do I need to cancel out, Curtis?
The grams.
So I got to find the relationship between moles and grams, right?
Mhm.
And that relationship is 1 mole is equal to the molecular weight.
294.30.
Exactly. Okay. Does that make sense to you now, Curtis?
Yeah, that makes sense. So I'm just not getting the math. So we canceled out the grams and we get 10 moles over 294.31, and then we just divided that. Okay.
You divided 10 by 294.31, and that's how you ended up with
And that's what we
0.034.
Okay, gotcha. Thank you.
No problem. Questions, guys?
I have a question. Where does the 294.31, like, where do we get that number?
Do you remember, Hayden? The first question we asked was, what is the molecular weight of this humongous molecule?
Oh, I didn't realize you were taking that number from that. Okay.
Yes, this whole number gives me the molecular weight. And I'm using that molecular weight to convert between 1 mole, or I can use this molecular weight to tell me how many molecules I have. The next question. How many grams is 1.56 moles? Okay, Curtis, start me out here. What do we know, Curtis?
We know we've got 1.56 moles.
Okay.
Wouldn't we have to know what element?
We're still talking about the same element.
Oh, same element. Okay.
All these questions, this was like a series of questions talking about aspartame.
Okay.
How'd you call that, Hunter?
Aspartame.
Is it really aspartame?
Yeah, I'm pretty sure the guy made it on accident too. It's a really cool story.
So, getting back, Curtis, what do I want to know from this?
So we're trying to figure out how many grams there are. So
Okay.
we take the grams over that number, the 2 something moles, what was it?
What? That's it.
Uh,
That is the molecular weight, 294.31.
Right. So wouldn't we take grams over 294.31 and multiply it by 1.56?
Grams divided by moles, right?
Right.
So the relationship I have is the molecular weight is equal to 1 mole.
Mhm.
So I know when I do this that that's always going to be a 1. And this is going to be. So all I have to do is multiply 1.56
by 294.31 over 1, and that's just going to be that number, whatever that number is.
459.
Okay.
Questions, ladies and gentlemen? Okay. Mila, we're still dealing with aspartame. I can't get it out of my head. Say it again. Aspartame, aspartame. We're still dealing with aspartame, Mila.
Yes, I'm gonna go step outside 1 second. They're just really loud right now. Okay.
I'll ask you the next one, Mila, okay?
No, we're good. I'm good.
Okay.
Oh, I left
You
it.
have 500 grams.
Okay.
You have 500 grams. I want to know how many molecules.
And this is still with the
Aspartame.
with that.
290.
Okay. 1 second. I'm sorry. I left my pen. These kids are wild. Okay.
It's hereditary. They get it from their parents.
They don't nap, and then they're extra wild, and you think when they're tired that they would just calm down, but it just makes them more crazy. 500 grams. So.
We're rethinking the motherhood thing tonight, then, are we? Okay. 500 grams is how many molecules?
So we know the molecular weight. Okay. So it's going to be, I set mine up differently than the way you're doing them. I think you're like skipping. Yeah.
You tell me what you do, and I'm going to tell you whether to continue to do it or not. Go for it.
So we're trying to see how many molecules it is. So I would do like 500 over X equals, and then that 294.3 over 1 molecule, and then like cross multiply, which would then get me 294.3 X equals 500 grams, and then divide the 500 grams by the 294.3.
Whoa, can we get a visual?
I'm giving you one right now.
I wrote it out.
Okay.
All right, thank you.
Is that like the right way it would be set up? Because then you would, to solve for X, you'd have to divide that out to get X by itself. I really like math, so that's where I like throw it to. Because it works.
I'm sitting here trying to see. I'm trying to think.
That one that the other boy did before me. I'm sorry, I don't remember who said it.
Curtis.
Curtis did before me. I'm sorry, that was really rude. That's how like I set that up, and then it gets it gets like the right answer. And then I did it on this one also, just to kind of see it for myself. I'm like, okay, so then you'd have to cross multiply and get X by itself. So you would
can't do that here, Mila.
Not on this one.
No, you can't do it. You can do it. All right. What you're relating. This is grams is equal to moles.
Yes.
As grams are to moles.
Yes. That's
all right.
how. Yes.
All right. That is when you can do that when you're converting grams to moles or moles to grams. But you're not converting moles to grams. You're converting grams to molecules. So you have to, instead of doing this gram to mole relationship, You have to develop a 500 grams to, okay, Mila,
Yes, I'm following.
this is equal to, now, Mila, you've got half of the relationship set up.
Okay.
So what are we doing? Look at the screen.
Okay.
You got 500 grams over, you don't know how many molecules that is.
Yeah. So it'd be like 500 over X equals, would I use the 294.3 in this
You
equation?
need, yes, you would.
Okay. So that,
294, do you know the relationship between 294.31 and the number of molecules that is?
well, no, because I don't know the molecules. Isn't
Yes,
that
you
what you're
do.
trying to solve it?
Yes, you do, Mila, because 294.31 is equal to Avogadro's.
Oh, which is that, my notes are inside, I'm sorry. The, was it like 206 times the 10? Okay. $602.
Okay, Mila, if you're understanding this better,
Yes.
then yes, you can do this.
Okay.
But where you were having problems is you were trying to do something with the wrong conversion.
Yeah.
Okay, so yes, this will work. If this is confusing anybody else, put your hands over your ears and say, dead kitty, dead kitty, dead kitty.
Sorry.
But yes, Mila, this will work.
And then you would just like, at that point, you cross
multiply.
Okay.
Because you're going to do the same thing. You're going to do the same thing when you do this.
Yeah. Yeah. That's just how you get there.
Okay.
Yes. Sorry.
No. That's fine.
It's just for my like understanding, I don't know why it's just easier to do like the something over X or X over something and then cross multiplying.
It's a different way of doing the problem.
Yeah.
What you're doing, Mila, what you were doing is not incorrect.
Okay.
All right. On the other hand, for the other 32 of you, if this is confused, if this ratio thing is confusing to you, drop it. Just do it the way we've been doing it from the beginning. You would take the 500 grams times Avogadro's number of molecules over the molecular weight. Grams cancels, and we are left with the molecular weight, which or the number of molecules. Divided by 294. And that ends up being 1.02 e to the 24th.
And then when you do that math, are you like doing it with the, are you like converting that 6.022 into a decimal? I'm sorry. It's not kids, it's dogs. It's nonstop.
Mila, the 6.022 is already in a decimal.
Okay, that makes sense.
All right.
Yeah, I get it.
Okay, I need to hear from you guys.
Sorry, I'm sure I just really confused everyone.
I need to hear from you guys. All right. We got about six more minutes left here.
I wish we
I'll-
had done this exercise before doing the quiz.
Sorry. All right. I want your confidence now, guys. I want your feeling. Do you feel confident that you know the material?
I was confident up until that last one. That one.
Yeah.
Curtis, I'll go back. Curtis, I'll go back and re-explain it to you. Okay.
Okay.
Talk to me, guys. How confident do you feel? At this point, I'm perfectly willing to give the test on next Thursday.
Thursday or Tuesday?
Thursday. I am perfectly willing to do that.
I'm still
How
stuck on
confident?
the balancing chemical equation somewhat.
I'm
That's
so stuck on the nomenclature. Like I've been reviewing, but that still confuses me.
Yeah.
Like the molar mass makes sense to me, but the nomenclature is kind of confusing me.
I don't understand that.
There was a problem because I don't remember if we did like balancing subscripts or not. And when I was doing the practice sheet that you gave us, I was just like, wait a minute, how did I have to pull it up because it was like bromine somehow got a
Okay.
subscript of 4 on the right side, and I'm like, where did you come from? I don't even know you. And yeah.
No, believe me, I'm from what I'm feeling right, what I'm getting right now, you guys don't feel confident. And I want you confident in this. All right. So let's do a review on Tuesday, test on Thursday.
Okay.
Awesome.
Are we good with that, ladies and gentlemen?
Yes.
Yes.
Yeah.
Yes.
Yep.
It's, to be honest with you, I didn't like the idea of starting something and then letting you go off for break anyway. So we are going to have the test next Thursday. We're going to review next Tuesday.
How hard is empirical and stoichiometry? How difficult is it? Or is it like
It's pretty difficult if you have like the ability to
Has
look
anybody
at
had-
online resources, but it's difficult.
Has anybody taken this course before?
Yes.
Who,
No.
I'm sorry.
Yes.
Who said yes?
I did it in high school.
Which one?
Okay. You guys answer Victoria's question. Empirical formulas.
I heard it's hard, it's okay, and it's fun. So really it's a mixed bag of emotions.
Okay, if
As chemistry is.
it's like if this doesn't make sense or like balancing chemical formulas doesn't make sense, then stoichiometry is gonna suck.
Yeah, there was just this one problem or a few where I don't remember us studying how to transfer subscripts over because
No,
I know
we
you
don't.
said
I don't
right.
want you transferring.
There when we go I'll bring it up on Tuesday when I look at the paper again, but I was looking at the answer sheet and I'm like, how
Was
did
it
I
in-
get a
Was it in the, Victoria, was it in the extra homework I gave you?
It was in the chemical reactions sheet that we can print out and do for practice. It was in there.
Okay, I'm trying to see whether I'm in the right. Yeah, I should be in the right thing. All right. The reason I'm doing this, guys, is I got a couple extra minutes. How is everybody feeling on the mole?
Good.
Hunter?
Yeah, good. Good on the wall.
That feels good. The moles feel great.
Yeah, the moles are all right. Just trying to
Okay.
get some other stuff. I'm happy we have the review up now.
Was it the balancing chemical equations?
Yeah.
Was the
And
balance?
I don't know if it was like a copy and paste error or something like that, but when I looked at the answer sheet just to like double check my work, there was like a bromine on the right hand side that had a subscript of 4 and I'm just like, where did you come from and how did I get
No,
you?
I felt that.
Okay. Reaction worksheet. We're going to go there. I think this is correct. Okay. Understand that I find these online, Victoria. So there could be errors in them. So just understand that. Do you know which one you were dealing with?
Yeah, it was I think it was the, oh shit. Sorry for my language. It had bromine. I believe it had bromine on it. That's all I remember was on the right hand side.
This
somehow,
one? Number
I think
8?
so.
Number 8?
Yeah, I think so. I need to pull up the answer sheet because it was.
Dear God.
Is
I
it
know.
okay to log out if we're good?
Oh, yeah, we're good.
Okay.
We
'cause
are
I-
gonna have a review on.
Sorry.
Tuesday, right?
Okay, it's Tuesday. We are having a review. Victoria.
Yes.
All right, look at the screen.
Yeah, I'm looking.
This is the answer sheet to that thing.
Oh, it was doing
This one?
the net. Yeah, the net ionic. I thought you didn't carry subscripts over when
You
you're.
don't. All right, what's the subscript on bromine here?
I can't see because it's 1.
What's the subscript on bromine over here?
It's 4.
So when I'm saying don't carry subscripts over, I mean that you don't just call this a 1 over here. Notice the nitrate is not converted to parentheses 4 there.
Oh,
That's what I'm talking about.
okay. I see what I you know what I didn't do? I was doing this at work, so I didn't multiply it by. Wait, no. Explain that again.
If you look on one side, if you look on the left of the equation, there's a coefficient of 4. So there's a bromine on the left, but on the right side, they don't need a coefficient.
All right, hold on a second. Let me get out of here. NABR and PbNO3, take them 4 times. Okay. Stop share. Share screen. Okay. You seen the slideshow again?
Yeah.
Okay, so we have NABR plus PbNO3 taken 4 times, right?
Right.
It was
All
4
right.
in ABR.
No, trust me, I'll get there. Okay. I understand what you're saying, but this was the original problem. Okay. Now, what does the lead go with? What does the PB go with?
It goes with the bromine.
Okay, so I got PB, BR,
Mm-hmm. And then
and
it's sodium nitrate.
all right. We just put them together. Okay. Now we would go to a chart at this point. We would take the lead and the bromine. We would find that that's a solid.
Okay.
Okay. So the reaction goes. All right. Now we have to figure out what the balanced chemical equation is. What the balanced chemical is. Okay. And that was where I told you don't carry over the subscripts, because to do something like this is wrong.
Mm-hmm.
You don't do that just because the subscript on this one is 4. You don't do that. That's what I'm telling you. Don't carry over the subscripts. Now, let's look at the PbNO3 taken 4 times.
Right.
Do you know what the charge on NO3 is?
Yes, because I actually have my guide out this time. It is -1 or 1 minus.
How many of them do I have?
Now 4.
4 of them. So if I have 4 of them, what's the charge on the lead?
Should be 4.
Okay. It's not going to change from left to right. So the lead is a 4 here. It's going to be a 4 over here, +4.
Okay.
Now, what's the charge on bromine?
Oh, good question. Isn't it like -1?
-1. So if lead is a +4 and bromine is a -1, how many bromines do I need?
4.
That's where the subscript came.
I thought I was losing my mind. I was just like, where? How?
So
why
actually-
is there a spawn of a 4?
Victoria, always ask a second opinion on that one.
Okay.
So that means you have to balance, like for the product side, you have to balance the charges on the compounds before you balance the equation.
Absolutely, Jennifer. Absolutely.
Okay, because that stumped me as well.
Okay. Now, let's look at Jennifer. Sodium. Do you know what the charge on sodium is?
Sodium is a +1.
And the nitrate, we just said a second ago, was a?
-1.
So if I have a +1 and a -1, is this one good?
Yes.
All right. Now, both of our compounds are balanced electronically. Now I can go proceed to balancing the equation. Are my sodiums good?
Yes.
Anybody can answer these. Are my leads good?
Yes.
Yes.
Okay. Now, I have how many bromines on the left, how many on the right?
We have 1 on the
4
left and
on the
4
left,
on the right.
1 on
Fix
the
it.
It would
Put
be
a 4 in
4.
front of the NA.
Yeah.
There we go. All right. Now, I have how many nitrates on the left and how many nitrates on the right?
4 on the left, 1 on the right.
Fix it.
Put the 4 in front of the NA.
You got this down. Who's talking? Amithia? Amithia, you got this down. Absolutely great. So at this point, go back and check. 4 times 1 sodiums, 4 times 1 sodiums. Good.
It's balanced.
1 times 1 lead, 1 times 1 lead. Good. 4 times 1 bromine for 4, 1 times 4, 4 bromines. Good. 1 times 4 nitrates, 4 times 1 nitrates. We are good. We're balanced.
Okay, I just want to say it one more time. So the compounds on the left are already balanced.
Have to be, Jennifer.
You create the compounds on the right to make the reaction. Balance those, then balance the equation.
Exactly.
Okay.
Exactly.
Okay. And that's for across the board, like when you're doing double replacement or net or anything like that. It's just, this isn't just for like net.
You need to finish, you need to get the complete chemical reaction in order to do the net.
Okay. And then the net is basically breaking down each individual one and seeing what the change is.
I have to put these things in.
Okay.
Okay.
Mhm.
And unfortunately, I got to kind of do this a little quick because I got to
That's
get
fine.
this recorded. So I'm going to do this by myself.
Sure.
I'm gonna take the font down a little bit because it'll make a little more sense then. Okay. Okay. Nah, not quite. Okay. Would you agree with that, guys?
Yes.
Now, what's the same left and right?
The sodium And the nitrate.
So I can literally eliminate those. And to tell what's really happening in the reaction, I got lead plus 4 Br minuses.
So the solids will always stick together like that? Okay. I understand. There's clarity. I'm getting it.
That's, hey, this stuff is not easy.
I think I was sick when we were going over this, so I don't think I retained a lot of the information, but I'm understanding it now. Thank you.
No problem. No problem
Mr.
at
P,
all.
can you show us where to find the test review?
Test review. Okay, circle it.
And
Okay, I hope I can, Curtis. All right, let's go back to, I need the table of contents. Okay, table of contents is there. If you go all the way down, do you see where it says practice test, Curtis?
yes, sir.
Click on that. And it's not going to be in this format, guys. It's probably going to be a multiple choice.
Okay.
But this is the,
Please. Oh my gosh.
you got to know the names. I have, I think 20 of them up there. 20, you got to do the names. Got to be able to determine a molecular weight. I have a thing where you have to predict the products, tell what kind of reaction, balance it, and for all reactions, briefly explain why it proceeds or doesn't proceed. Okay, guys, I have this big thing with heat. I'm not, let's blow that off. I'm not going to give that one to you. This is a decomposition reaction. Okay, what kind of reaction is this, guys? B, I'm talking about B.
Double replacement?
Double replacement. So my products are going to be FeF and NH4SO4. Okay. C, what type of reaction is C?
Also double replacement?
I would accept that.
Acid base?
Acid base. Acid base is the more better answer, but I would accept a double replacement reaction.
Oh yeah, the O8. Yeah, okay.
What about D?
Single replacement?
Single replacement. Copper is more active than silver. Does the reaction proceed?
Yes.
And I had to tell you this little information there. So what happens is if the reaction goes, you're going to get copper as a +2 reaction.
So it'd be like copper 2.
So it'd be copper parentheses NO3 taken twice.
Excuse me, I have a question. If I were to print off a list of like least to most active elements, is that permissible?
Yeah, you can do it, Hunter. Hunter, I'm going to give it to you, but if you want to do it, go for it.
Okay, no, I just like to have like
I'm going to
extra
give
resources.
you. I'm going to give you in the test. I'll give you a periodic table, a solubility chart, and an activity series.
Yeah, we're allowed to have any notes as long as it's not another open browser.
Of course, yeah,
Correct.
of course, of course.
What about E? What kind of reaction is E?
Combustion.
Victoria, you got these down.
I'm getting there.
Combustion is that oxygen.
I wasn't sick when we were doing combustion.
Hunter, what was your question?
No, I'm saying it gives it away when you see the C, the H, and the O in there for being a combustion.
Further on here, I have you do a balanced equation, a balanced ionic, balanced net ionic, and I say a couple things you need to make sure you indicate everything. This is just a hint for you. and you got to indicate the type and quantity of charge. Again, those last two things are hints for you to do. Then I have a whole series of doing calculations going from milligrams to moles, liters to mole. Oh crap. Somebody needs to remind me. I need to show you one more conversion. There's one more conversion I need to talk about.
Is there an answer sheet for the practice test?
Yes.
Yeah,
As I
it's in there.
said,
He uploaded that one.
yes, I did. But again,
Don't go by
don't
it.
trust it. Do not trust it completely. If you come across an answer that doesn't match what you think it is, email me and I will look at it.
Okay. Also, do you mind if I
There's
leave?
the answer. No, as a matter of fact, I got to leave because I got to get this thing. I got to get the recording uploaded. Okay, guys.
All right. Thank you,
Thanks,
Professor.
thank you.
Review on Tuesday, test on Thursday.
Got it.
Sounds
Thank
like a
you.
plan.
Bye.
All right. Take
Bye.
care. Anybody have anything? Okay, guys. Omar, are you there? Omar, are you there?
Yes.
Okay. I'm cutting you off now, okay?
I'm sorry, you said what?
I'm stopping the meeting.
Oh, okay. Thank you. Have a great day.
You have a great day too.